NCBM 0324, Section 1.7, Solving Quadratic Equations with the Quadratic Formula, Part 2. Now that we have an idea of where this quadratic formula is coming from, let's try it out on some examples. Example 1, we want to use the quadratic formula to solve each equation. Part A, 5x squared minus 14x minus 3 is equal to 0. So comparing this to our setup of our formula, it looks like we're in the right form. We have the variables and our constants on one side of our equal sign and a 0 on the other. So I'm in the good starting point. Then I'm going to have to pick out my a, b, and c to be able to plug them into my formula. So your a value is always going to come from the x squared term. Now the variable doesn't go with the a value, it's just the number in the front. So in our case here, that's just the 5. It's not 5x squared, the a value is just the 5. Then we'll do the same thing for the b. b is in front of the x term, so negative 14, watch those signs. And then our c value is the constant, the one that doesn't have a variable. In this case, it's negative 3. Again, be mindful of your signs. That's where a lot of times we can make a mistake. So once I have my a, b, and c written out in this way, I can begin plugging in my numbers. So my formula goes negative b. So there's a negative in the formula, but I also have a negative in my value. So I'm going to put my value in parentheses to make sure I remember. There's a negative from the b and a negative from the quadratic formula. Then I have this plus or minus square root. My b is negative, so when I square it for the inside part, I'm going to put parentheses to make sure that I square all the parts of b. Then the rest of my formula, minus 4 times a times c. So I have a lot going on inside that square root. All of this is going to be divided by 2 times a, which is 5. So plugging in, a lot of parentheses in here. We got to make sure we're treating the signs as we need to. We're not losing any of the signs either. We got to make sure it's all in place. Once we have all our values plugged in, that's when we can start to simplify. And again, we're using our order of operations. So I want to get rid of a lot of these parentheses first, the multiplication, and then we'll slowly work our way down to the answer. So in the starting up here, I notice the negative and negative, all that turns into a positive 14. Then I have this plus or minus, and I'm going to do negative 14 squared. Remember, when you square a negative, it's always going to be a positive, and 14 squared then is 196. Then I have minus 4 times 5 times negative 3. Well, that negative from the 3 and the minus is going to turn into a plus. 5 times 4 is 20, times 3 is 60. Divided by 2 times 5 on the bottom is 10. And we can keep going. I'm going to have 14 plus or minus, we'll keep that going there. 196 plus 60 is 256 divided by the 10. So now I have 14 plus or minus. Well, in my calculator, I can do the square root of 256, and that square root is a nice 16 divided by the 10. Now at this point, maybe you've been wondering, what does this plus or minus mean? Well, that plus or minus is in front of that square root, right? We eventually got it to reduce down there, but that's where that plus or minus originally started. And that has to do with that square root property we discussed in our last video. When I take the square root of something, I have to consider the positive and negative of it, right? To consider the signs when we square something. So that's where it's coming from, which then means I'm eventually going to have to break it up to get my answers. So one of my answers, I'm going to have the situation where I'm going to have 14 plus 16, the plus version, divided by the 10. And my other scenario, my other solution is going to be 14 minus the 16 divided by the 10. So you're splitting up that plus case and then the minus case. So 14 plus 16, well, that's 30, divided by 10 gives us 3. So that's one of my x values. X is equal to 3. The other one, let's try that one out. 14 minus 16, well, that's negative 2. Negative 2 divided by 10 is negative 1/5 reduced down. So there they are. I have my answers. Now, since we're solving something, we're finding the x values that make this equation true, we can always go back to our regular forms of checking. If these are in fact the answers, if x does equal 3 and negative 1/5, I could take that 3, plug it into the x of each of my values over here, and it should come out to equal 0. And the same thing with the negative 1/5. So if we were solving something, you can always check it by plugging it back in. Let's try another one. Let's try out b. We have y squared plus 5y plus 3 is equal to 0. So even though we have a different variable, we have a y, it's still in the right form. We have that variable squared plus 5 times the same variable plus a constant equals the 0. So we're good to go to use the quadratic formula. We still need our a, our b, and our c. So our a value here is 1. There's a 1 in front of that x squared. The y squared. So 1, a nice positive 1 is our a. Our b value is a positive 5. And our c value is a positive 3. So let's take our quadratic formula. We'll make this y equals since that's our variable. But I'm going to follow the same setup on the other part of the formula. So negative b, well, that's negative 5, plus or minus the square root of 5 squared minus 4 times a times c, so that's 1 times 3. All of this divided by 2 times 1. Let's see what we get up top then. Let's start simplifying this. That negative b, that's going to stay negative because I don't have another negative to reduce it down. I have b squared inside the 5 squared. That's a positive 25. This is going to stay minus, let's see, 4 times 1 times 3. So that's minus 12 divided by 2. So from this point, we want to split it apart. We want our version with the plus and one with the minus. So I'm going to have y is equal to negative 5 plus the square root of 13 divided by 2. Go ahead and do the other one down here. Y will equal negative 5 minus the square root of 13 divided by 2. Well, at this point, we'd want to check our instructions, see if it wants the answer in exact form. If it doesn't mention any decimals, then these would be our answers. The square root of 13, 13 is prime. We would have to use a calculator to find the square root of 13 value. But if we wanted to practice decimals, we can do that. We can look for the approximation of these square root values. And again, we do need the calculator for that. So for the plus version, negative 5 plus square root of 13 divided by 2. Order of operations, I want to do the numerator first before I do the division. So I could say negative 5 plus the square root of 13. That's my decimal version of the numerator. Divide that by 2. And I end up with an approximation of negative 0.697, we'll say. We'll round it off to that value there. So this is an approximation. It's not exactly equal to. The exact answer is the version with the square root. And we would do the same thing for the negative side, the subtraction version. And in that case, we'd end up with a negative 4.303 when it's rounded to 3 decimal places. Now make sure you practice with your calculator. Every calculator is a little bit different when it comes to the notation. This particular calculator does have the nice square root symbol where you see the little little house of the square root that we know, but your calculator may have it a little bit different. So always make sure you know your own calculator and how to enter things. So then to summarize this last one, we have our solutions in two forms, right? Two forms for each of our answers. And I could still take these, plug them in, make sure they equal to 0. If I take the decimal, it might not be exactly 0, it might be a little bit off, but that's just because we rounded. We didn't use all the digits from that square root. So that's the quadratic formula. Really useful. It'll give us some interesting answers. Sometimes, factoring is a little bit faster, but sometimes we can't factor everything, right? So we need other skills to be able to solve these quadratic equations.